As modern technology continues to advance, the search for clean and renewable energy becomes more prominent each day. Scientists and engineers alike are always on the search for alternative sources of energy that can be easily distributed among developed and underdeveloped countries. Here's where the power of the potato comes in. It's long been discovered that a battery can be created from many different things, including vegetables such as potatoes. This crop-based power system has been found to provide rooms with LED-powered lighting for as long as 40 days and are significantly cheaper than your average battery. In order to create a potato battery, only two metals are needed: a negative electrode known as an anode, and a positively charged electrode known as a cathode. A common anode and cathode used in circuits are zinc and copper. Energy is released when the acid inside of a potato forms a chemical reaction with the zinc and copper. As this reaction is occurring, the electrons flow from one material to the other, and a potato battery is created. The flow of electrons can be referred to as a current. This experiment aims to observe the effect of the quantity of potatoes used in a circuit in relation to the amount of energy produced as the number of potatoes increase. This is tested by measuring how bright the light bulb will shine as each potato is added to the circuit. When we look at a circuit with regular batteries, such as this one, we can see how the electrons flow within the circuit. As we add more batteries to the circuit, we can see that the light bulb shines brighter and brighter. The hypothesis for this experiment is that as we add more potatoes to the circuit, the light bulb will shine brighter and brighter. The materials needed for this experiment are 4 russet potatoes. Any kind is fine, but for this experiment, I used russet potatoes. 4 copper strips, pennies are also fine. 4 zinc strips, galvanized nails will also suffice. A 1.5 volt LED light bulb, a copper wire cut into 5 even pieces, and a lux meter. The experiment will start with 2 potatoes. Connect one end of the copper wire to a copper strip and the other end to a zinc strip. Stick each strip into 2 different potatoes. Connect a different copper wire to a different zinc strip and stick this strip to the potato containing the copper strip. Repeat with another copper strip. Connect the other end of these wires to the light bulb, with the cathode connecting to the positive end and the anode to the negative end. Repeat these steps to add a third and fourth potato to the circuit. Measure the brightness each time using a lux meter. At just 2 potatoes, the lux meter presented a reading of 0.00 lumens. 2 potatoes weren't enough to power the light bulb. However, when a third potato was added to the circuit, the light bulb began to shine. You can see at the table here that the lux meter measured a reading of 8.26 lumens. At 4 potatoes, the brightness of the light bulb didn't seem to have any observable change to the naked eye, but when measured with a lux meter, we can see that the brightness jumped up to 9.07 lumens. That's almost as bright as a candle. This data produced an R-squared value of 0.8164, which means that the data represented an 81.64% correlation of the number of potatoes to the brightness of a light bulb. It can be concluded that the more potato batteries present in a circuit, the brighter the light bulb will shine. With even more potatoes, it's safe to say that this method of producing energy can be sourced and developed at a larger scale.